Right, what we're going to look at here is error intervals. Now, we get error intervals when we round something. So if we work backwards from our rounded answer, we could have had a number to begin with that was between two values, okay? And that's what we're looking for. We're looking for those two values. And once we write that down, that's our error interval. So the best way to do this is probably just to do a few examples. So example one is a number is rounded to 22 meters to the nearest meter. So basically I could have had a number slightly bigger than 22 and it was rounded down, and a number slightly smaller than 22 and it was rounded up. But the thing is, we don't know exactly. So what we do is we say, well, this number could be between this one or this one, and we give them a range of numbers. So best way to do this is looking at what it was rounded to. It was rounded to the nearest 1 meter. Okay, so rounded to the nearest whole meter is really important. And it was rounded to 22. So I put 22 down because that's our starting point. It tells me it was rounded to the nearest meter. So I'm going to take 1 meter off and add 1 meter on. 1 meter off, 1 meter on. And these aren't our areas. It's not, I didn't have a number from 21 to 23 that rounded to 22, because if it was 21 then it would be 21 anyway. But what I do is I take the middle point of these numbers with 22. So the middle point of 21 and 22 is 21.5. The middle point of 22 and 23 is 22.5. And these are now my bounds for my interval. And I'll explain what bounds are. But basically, my number could have been 21.5 or above or higher to be rounded to 22. Okay, so 22.5, and my biggest my number could be is 22.5. Although 22.5 rounds to 23, we say it's so close to it that we actually take that number. And the number must have been less than this or greater than or equal to this. And that's what we do. So we use like an inequality. This lower number is what we call the lower bound. And this bigger number is what we call the upper bound. And this is what we call an error interval. Okay, so x was the number that we rounded to get 22. We don't know what it was, but we know it's got to be less than 22.5. Oh, sorry, this was 21.5. And greater than or equal to 21.5. Okay, so this 21.5 comes down here. This 22.5 goes there. And these inequalities, this less than or equal to stays the same, and this greater than or less than stays the same. Okay, that was a 1 there. My mistake. Right, let's do a second example where it changes slightly, and hopefully you slowly get to see what's going on. Okay, so a number is rounded to 1 decimal place to get 15.6 centimeters. So I'm going to write down the error interval for this original number. So remember 15.6 is where we start. That's the bit in the middle. I want to add on 1 decimal place, so that's 15.7, and take off 1 decimal place, so that's 15.5. The bits in the middle are going to be our bounds. So the bit in the middle of 15.5 and 15.6 is 15.55, and the bit in the middle of these two is 15.65. These are my upper bounds, so I just need to write my inequality. So my number must have been less than 15.65, but greater than or equal to 15.55. And it's that simple. It's not a lot of workings. Shouldn't be something we get. If we can remember the method, then it's nice and easy to do. So remember, this is 15.55 is your lower bound, and your 15.65, which could have been your smallest value, is your upper bound. 15.65 is your upper bound, which would have been your biggest value. Right, last example. A number is rounded to 2 decimal places to get 13.79. So now I want to write down the interval for something that's been rounded to 2 decimal places. So 13.79 is my number. Remember, I need to go up a second decimal place and down a second decimal place. So I'm going to go up 1 from 13.79 to 13.8. And then I'm going to do down 1 from 13.79 to 13.78. The bits in the middle. Right, the middle bit of 13.78 and 13.79, well, it's just add on a 5 to the lower number. So that's 13.785. For this one, it is just add on a 5 to the lower number, so it's going to be 13.795. And these are my bounds for my intervals. So we've got x must be less than something or greater than or equal to something. 13.795, 13.785, and you're done. Okay, if they wanted your smallest possible value, then that would have been this first number on the left-hand side. Okay. Right, have a go at some questions, and I will speak to you soon.